Hello everyone, welcome back to my tutorial. In this tutorial we are going to solve assembly of two cylinders. So this is the first cylinder and this one is second cylinder. The dimensions are specified here. The boundary condition is we are going to fix right side surface, and here we are going to apply pressure of 30 megapascal. Both the cylinder having a material property of 180 gigapascal, Young's modulus and Poisson ratio is 0.25. Now we will solve this problem using code aster. Just open. Here I have kept my salome file. Just open the terminal here. This is the command to open the salome. We are going to solve this problem using salome version 2022. Salome is got open. Now we can go for geometry model. So this problem is taken from the calculus. Now we will model the geometry using geometry module in salome. So first we'll create a diameter of first cylinder of 80 mm and length of the first cylinder is 100 mm. We are going to use a unit of meter, so we'll convert this into meter. First cylinder, we can directly go into this. So there is option to base point, vector is x vector. Here so later we will scale it, so whatever is specified there we will specify it here. So first go to the model, 80 mm diameter, that means 40 mm radius. So 40 mm 0. Divided by 1000 we need to specify it. 0.04 is a 40 mm and length they have specified is 100 mm, that means 0.1. So this is the first cylinder, radius is 40, then apply it. The second cylinder we need to specify same way of diameter of 50, that means radius is 25 and length is 120. 0.025 and length is 120, that means 0.12. Then apply and close. Now we just go to the case. We need to move our volume 2, that means cylinder 2, into this location. So of length 100 mm. So just go to here, select the cylinder 2, operation, translation, transformation and translation. In x direction we need to translate into 0.1. Now see it has translated. This is the preview it shows. There is an option called create a copy. We can generate a second model also, or we can translate without creating also, we can do it. I just go to create a copy. Now I the old one, this one and this one. Now see both are coming here. Two cylinder, we need to keep these two cylinders separately. Okay, so now just go to the salome. This is the first cylinder and second cylinder. First make it into compound. Go here, there is an option called build compound, then apply and close. Now select this compound, go to new entity, there is an option called explode, solid, apply and close. Now see in this compound we have two solids, solid 1 and solid 2. So if you use this compound 1 for meshing, what it will do, it will generate separate meshing. So it will not generate a element connection between the cylinder 1 and cylinder 2. To make element connection, node connection, what we need to do, we need to do partition between this object. So for that, so I will create one surface group. This is the surface I wanted, apply and close. Based on this surface we need to partition it. I'm just saving this file. Now we can go for operation, partition. Select this solid 1 and solid 2. Use the tool object as group 1. The resulting type has to be a solid. Apply and close. Now we have created the partition of two solids using image surface. Now we have partitioned it. Now we can go for explode, solid, apply and close. Now we have two solids. It has the connection between the surface. Okay. So by slicing we can see it. Go for there is an option called clipping. I will save this. This is actually a transparency. Okay, we'll see that one later. So now we have created this model. Then what we can do, we can go for grouping. We need to create two groups. One is fixed group. Here we need to fix it. Another one is we need to apply a pressure here. So just go to the salome meca. We have volume 1 and volume 2. Any name we can give, V1, V2. Both are same material. So in this case both are same material. Okay, just go for create groups, group, create group, surface group. Here we need to fix it, apply. Here we need to apply pressure. Both we have done. Now go for meshing. Mesh, create mesh. NetGen 1D, 2D, 3D. Simple parameter we can use. 0.02 it shows, 0.5 I am giving. Save OK, apply and close. Right click, compute. So this mesh is enough. This mesh is captured the surface nicely, and this mesh is enough for me. Now the groups also taken into the mesh. You can see it here. Now we can save this file. Now we can go for solving. Just go to aster study. This is simple linear static analysis. We can use a wizard to generate the command file. So just right click here. There is an option called add stage with assistant. There is an option called isotropic linear elastic model. So here we can, these two boundary condition only we are applying. So this is enough to generate the command file. Mesh 1, 3D. Here we need to specify the material property. This is a 180 gigapascal. Instead of 210, you just change into 180. And this is make it 0.28. So we'll confirm the 2.5 actually. So 2.5. Say next. Impose the degree of freedom, that means fixed boundary conditions. So fix, save OK, 0, 0 and 0. That means we are arresting the displacement. The next one is pressure on the mesh group. This is pressure. The value of pressure value is 30 megapascal. We need to specify in Newton per meter square. So 30 e power 6. Say next. We need to specify the file name. Go to pictures, code aster. Here I'm just giving a name called result.rmed. Already is there, so we need to name it result1.rmed. So this is the name I'm giving. Save it, finish it. So after generating, specifying the setup, here we can check it. So the read and mesh, material is mechanic, material is assigned to all the model. So okay, 2 groups, results and solver. What it will do, it will only generate and save the primary variable displacement. If you want to see vonmises stress, everything, and directional stresses, principal stresses, we need to go for post processing. So just go to post processing. There is an option called calc champ. Give the same name as result. Now there is an option called constraint deformation energy. In constraint, we can choose sigma SIGM element SIGM node. Element LNO is nothing but element. This is nothing but node. Sigma means nothing but directional stress. This thing we don't want strain energies. Criteria is nothing but equivalent stresses. So I want a equivalent LNO node, element and node. Vonmises stress, we want element and node. So if you want reaction force also, we can go for force, reaction force. Go for model material, we can tick it, just apply it. So now result is came. It is calculating the other variables from the primary variables. Now we can go for output. Just change the output, edit. This is not meca static, actually calc champ. From that we need to calculate mesh. We can tick it. There is an option called tau champ. We make it S. Tau champ is nothing but all the values. Whatever the value we are calculating in calc champ, it will ask us to save in the result page. So by giving S means it will save all the files. Another way is we can go for norm champ. We can specify what are the values only we need to write it in the result files. That is we can do by using norm champ. This is, it will write all the results. Okay. Now we just say OK. Just apply it. Say OK. Now everything is done. We can save this file. We can go for history view. We can run the calculations. Just wait for a while. It will solve and calculate the results. If you want to go for very accurate results, we can go for higher order element also, and we can do for mesh convergence study also. We can increase the element size by making finer and finer. We can study the results, how it is getting varying. And one more study is by changing the polynomial. So now we are using a linear element. Instead of linear element, we can go for higher order element, quadratic element also. Now it is getting solved. See, now we can view the results by using paraview. I'm just saving here. Go here, paraview. Just open home, pictures, code aster, result1.rmd and apply it. Now in whatever the results here you see, everything is saved here. So which one you want to see, that one we need to choose. Example, displacement. This is the displacement value. Similarly in directional, this is actually a magnitude. Similarly we can go for directional also. X means compressing, that's why it's showing like this, compressing negative value. Similarly go for directional stresses, sigma x, Similarly, we can go for equivalence vonmises. So it's coming around 390 megapascal. So to weave in blue to red, just simply change this into rainbow, and another option is called this one. Just edit it into 12. Just move it here. This way we can see it. Because of sudden change in the cross section, here it's getting little higher stress. Thank you for watching my videos. Please subscribe my channel for more video. Thank you.